So we have our question 3 on the board. It says, in a GP, the fifth term exceeds the fourth term by 24, and the fourth term exceeds the third term by 8. Find the common ratio and the sum of the first 5 terms. Now, we're going to take it gradually. We're going to interpret each statement so that we can get it clearly. The first statement here says, the fifth term exceeds the fourth term by 24. So what does it mean? The fifth term, that is T5, exceeds, which means if I say T5 minus the fourth term, which is T4, I will get 24. So a simple way to understand that is if I say 9 exceeds 5 by what? 9 exceeds 5 by 4. What it means is that 9 minus 5 gives me 4. So this exceeds means we can turn it into a subtraction. So the fifth term exceeds the fourth term by 24. This is what it means. And in the same way, the fourth term exceeds the third by 8. The fourth term exceeds the third by 8. So that means T4 minus T3 equals 8. So these are what these two statements are. Now we're going to bring out the expression, because for us to even find the sum of the first 5 terms, which is the second question, we need to know what the common ratio is and what the first term is. So they've given us an information that can help us find these two. So now let's go ahead and bring out the expression so that we can find the common ratio and the first term. So what is T5? Remember that the nth term of a GP is given as Tn equals AR raised to the power of n minus 1. So in the case of T5, it's going to be AR raised to the power of 5 minus 1 minus AR raised to the power of 4 minus 1 equals 24. And so what's 5 minus 1? It is 4. So we just replace it with 4. And 4 minus 1 is 3. So we replace it with 3. So that's what it means. So we've interpreted this one. Now let's bring out the expression for the second one, and which is T4, which we already have here to be A raised to the power of 3, AR raised to the power of 3, minus, so what's my T3? That is AR raised to the power of 3 minus 1, and 3 minus 1 is 2. So I'm going to write 2 here, which gives me 8. So this is my first equation, and this is my second equation. So now, what am I going to do here so that I can eliminate something and find the other? I have to be very careful. And why? So remember, the first question says find the common ratio. Now, we've never really had something like this before, all right? We have AR in one equation. So what are we going to do? So here we are going to factorize each of them, and you see what happens, okay? So how do we factorize this? What do you see here that you could see here? So you see, this is AR raised to the power of 3, okay? It is smaller than AR raised to the power of 4. So we can find all of this inside here. It means that AR raised to the power of 3 is the highest common factor between the two here. So I'm going to have AR raised to the power of 3, open a bracket. So AR raised to the power of 3 times what will give you AR raised to the power of 4? It will be multiplied by R. So that's why R raised to the power of 3 times R raised to the power of 1 will give you R raised to the power of 4. And then your A times 1 is A. So minus AR raised to the power of 3 times what will give you AR raised to the power of 3? That is times 1 equals 24. Okay, now the next one. You can see this one, AR raised to the power of 2, is smaller than AR raised to the power of 3. That means you can find this one inside here. So that means this is the highest common factor between the two. So now I'm going to have my AR, I'll factorize it out. AR raised to the power of 2, open a bracket, times what will give me AR raised to the power of 3 times R. Because R raised to the power of 2 times R will give me R raised to the power of 3. Remember laws of indices. Now minus 1, because AR raised to the power of 2 times 1 will give me AR raised to the power of 2. So I've successfully factorized this. So at this point, I can now confidently say divide equation 1 by equation 2. Yeah, because you can see these are multiplying each other now. So I'm going to divide and you see what happens. So when I divide equation 1 by equation 2, what happens? See, A will cancel out A, okay? And when you see r raised to the power of 3 divided by r raised to the power of 2, remember the laws of indices. Just take one of the r. 3 minus 2 is 1. So that means you're having your r. And then this r minus 1 will cancel out r minus 1. Then 24 divided by 8 is going to give me 3. So your common ratio just fell out. It just dropped out. Your common ratio is 3. We've gotten our first question. That is our I. So we've gotten it. So now I need to find my first term, which is A, before I could even go ahead to solving this one, because I need A for this. So what's my A? Just go back to any of this and impute the value of your common ratio, and then you're going to find your A. So we're going to use the second one here, all right, which is AR raised to the power of 2 bracket R minus 1. So wherever we see R, we're going to put 3. So this becomes A times 3 raised to the power of 2. Open this bracket times 3 minus 1, close, and it said it is equals 8. So what's 3 to the power of 2? That's 9. And 3 minus 1 is 2. So 9 times 2 is 18. So we're going to have 18A equals 8. So we divide both sides by 18. And my A becomes, so 2 goes in here 4 times, and 2 goes in here 9 times. So my A becomes 4 over 9. And that's my first term. My first term is 4 over 9, and my common ratio is 3. Now let's solve the second one. And the second question says the sum of the first 5 terms. So first of all, our common ratio is 3, and our first term is 4 over 9. So since our common ratio is 3, what formula are we using? We're using this one, where the common ratio is greater than 1, which is Sn equals A into R raised to the power of n minus 1, all divided by R minus 1. So this implies, let's just impute the values. My A is 4 over 9, which is 4 over 9. Open your bracket. And so what's my R? 3. 3. So raised to the power of n, what's the number of terms? It says the sum of the first 5 terms. So the number of terms is 5, which is 5, minus 1. Close the bracket, all divided by R minus 1. And my R is 3 minus 1. Now this implies, so my 4 over 9 is still here, multiplied by, so what's my 3 raised to the power of 5 is 243. So 243 minus 1 is 242. So all divided by 2. Okay, so this implies, so my 242 multiplied by 4. What's 4 times 242? And that gives us 968 over 9 divided by 2 over 1. So this implies 968 over 9 times 1 over 2. So 2 here 1, 2 here goes 4, 8, 4. Yeah, so that's 484 over 9. So the final answer is 484 over 9. And that's the sum of the first 5 terms of this GP. I'm going to give you something to do now, all right?